Okay, I'm going to give you a demonstration of how Concept works, how quickly it is to build the model and the type of analysis results you can get out. So, this is the Concept interface. You can see I'm adding in 3 shafts into the model. These shafts are real engineering objects. They have a mass, they have a density, they have a stiffness, and they have an inertia. So these aren't just lines on the screen, these are proper engineering objects. So we can position these, we can position them in each of the planes, we can define a center distance. You see here I can lock the center distance to be a particular length, and then we can move the components about as we see here. So we've got complete freedom to either move things by hand like this, or we can type in a position or a dimension. You can see here we've got these 3 shafts positioned in space, so I'm just checking that I'm happy with that, and that seems fine. Okay, I'm now going to go through and add gears onto each of the shafts. So what I'm going to build up here is just a very simple 5-speed manual transmission. At this stage these gears are just represented as simple gear ratios. I'm just connecting the gears together as we see. And then we can modify the ratio of each of these gears. I can either drag and drop the mesh as we see here, or I can type what I want the ratio to be. And as I say, at the moment these gears, we're not considering gear teeth, these are just discs. This is just to get a particular gear ratio defined. So I've done that for each of the gear meshes, and I'm then going to say where the power comes into the gearbox and where it comes out of the gearbox. I then need to say that these gears aren't all going to be rigidly fixed onto the shaft, they're going to be free to rotate. So this represents either a clutch or a synchronizer. I then want to define the power flows. So as I said, this is a 5-speed gearbox, so I'm just going to click through each of the power flows in turn. So this is my 3rd speed, and I'm going to look at 4th speed and 5th speed. And you can see how quickly we can define the power flow, and we can do something very similar if it was a much more complicated gearbox as well. Just again looking at the 3D model, so you can see we have all of the load cases defined, and we can see that we've got all of the speeds are calculated for each of the components very quickly. Just looking at some of the results that we have now for each of the load cases, you can see we've calculated the speed ratio and the torque ratio automatically, and we also have the speed of each of the components for each of the load cases that we've defined. I'm now going to add in the bearings that are going to support these shafts. So we've got these, so I need to add 6 bearings in to support the 3 shafts. You can see I'm just adding them and connecting them to ground. So there's my 5th bearing and there's my 6th bearing. So these bearings are connected to ground. We can then look at the bearings in a bit more detail, and we can see that these bearings are taking a load in the directions that you specify. So this is completely user definable, and we can then look in the reports tab and we can see what the bearing forces are. So this is a very valuable piece of information that you can pass to your housing designer, and he can use these to help him in his housing design. What we can then do, we can actually calculate the bearing dynamic capacity. So we can select from, in this case it's either a radial ball bearing or a cylindrical roller bearing, and based on the dimensions, based on the required dynamic capacity, the software searches the bearing catalogue and gives you a suggested bearing. And this is a really good way of getting an initial idea of what bearing is going to be suitable for your specific application. We can then look at the bearing load ratings and life ratings, and these are calculated to various ISO standards. So that was bearings. Now looking at the gears, we can then start to look at tooth modules for the gears, and the software will suggest tooth numbers. So we're starting to add more detail onto the gear. We can then take it a stage further, and we can do a real detailed gear design. So we have all of the gear parameters here. All of these parameters fully define the gear geometry, as well as how it's going to be, as well as giving you a picture of the gear that we can see here. And we can also do a very detailed gear rating based on these parameters. And the software can design the gear for you and really give you a lot of help on the gear design process. So you see here we've got the complete gearbox. We can see the forces that are generated at the gears as a PDF report. And these forces, as I say, are very useful for the housing engineer, the housing designer. Here's our 3D model. Again, we can see the forces that are being generated, and we can see this in a completely interactive format. We have a load of other results as well. So you can see here just some examples. We can look at tooth passing frequencies. We can do a detailed gear rating. We can do ratings for clutches, bearings, and we can look at all of the loads that are generated, as well as looking at efficiency and as well as looking at a vehicle performance. So hopefully that gives you a good idea just how quickly you can build these type of models and the type of analysis results that you can get out from the simulation. Okay, I'm now going to show you how we can use Concept to build a much more complicated transmission. In this case, it's an 8-speed automatic. The first thing we have to do is to add the 4 planetary stages that make up the transmission. So we go into the Gear Tools toolbar, we select the planetary gear set, and then we add it into the workspace. This is the first one, and then we need to add in the second, third, and fourth planetary gear sets. At the moment, these are planetary stages with 3 planets, but we can change that at a later time. We then need to add in the connecting shafts to connect these planetary stages together. So we can simply drag and drop each of the individual shaft components, and we can put steps in, and we can change the diameter of each of the stages. So we're just going to go through now, dragging and dropping each of the sun shafts, the planet carriers and the ring gears to make sure that we have the right components connected together. As you can see, we're simply dragging and dropping each of the components, and then we can merge the shafts together to make the connections that we need. So you can see here we're connecting the 2 sun shafts together, and we're connecting the planet carriers and the ring gears in the appropriate way. This is a very easy to use function. It's like having a PowerPoint drawing. We can just connect components together. In this case, we need to use a rigid connection to effectively glue the components together. We can easily zoom in and out, and we can just build up all of the connections in a very quick amount of time. So we're nearly there. Just got a couple more shafts to modify and to stretch and to change. Need to pull that sun shaft right through and so on. Okay, so we've now set up all of the shafts, we've got all of the connections and we're happy with them. It's now important to set up the brakes and the clutches. So these brakes and clutches are going to be connecting different parts of the system together. So I select the clutch component and I then add it to the appropriate positions. So we have a clutch between these 2 shafts, we have a clutch between these 2 shafts, and so on. So in the end, we're going to have a clutch between 3 of the shafts, and we're going to have a brake to housing at 2 positions. So these 3 clutches and 2 brakes and different permutations are going to give us the different load cases. So I'm just going to say the power comes in at this point and comes out at the end of the gearbox. We then have to define the clutch states for the 8 forward speeds and the 1 reverse speed. So for each speed we have different permutations of the clutches and the brakes engaged. There are different ways to define this within the software. In this case I'm just going to select each of the load cases and then select which of the clutches are engaged. And as soon as that red light turns green, we know that we've properly defined the state and the torsional model is properly defined. So we're just going through each of the states, the 8 forward speeds and the 1 reverse, and defining the clutch states. Very, very easy to do, and the software is guiding you and helping you to explain when the clutch states are correct. And as soon as we've done that, all of the speeds, the forces and the torques are calculated, You can see here that we have the input speed and the output speed automatically calculated for each of the clutch states. And then we can see we've got a 3D model of the gearbox with all of the individual first speed to 8-speed conditions are defined, and all of the speeds, and we can see we've got a 3D representation. And of course we can take this further and do much more detailed design and analysis, but hopefully that's given you a really good understanding of just how quickly you can build up such a complicated gearbox using Romac's concept.